Hello friends, welcome back to the channel. In this video we are going to configure a network with the dynamic routing protocol having more than one route, and we are letting the routers to decide what route they should follow. Means the route should be shortest with less number of hops in the network. And in earlier videos we have configured the network for dynamic routings where we were having only one route, but here we have the multiple routes in the network and we will see how the router is going to choose the shortest route. So let's start. Here the dynamic routing protocols are RIP, OSPF and EIGRP. We have done the dynamic routing with all these protocols in the earlier videos, but this time we are going to use RIP, only the RIP protocol to configure the network. You can also try this practical with OSPF or EIGRP, it's up to you, but we are not using the static routing here because the static means the defined route. Okay, so we are working dynamically where the routes can be decided depending on the present network conditions, means number of hop in the networks or number of hops in the path, or whatever updations are in the network must be considered to decide the next route. So here this is the network that we are going to use. Here this is the network, we can say that with ID 10, and this is the network with ID 20. We are using class A addressing. Okay, so we have two routes available within this network. One is this route and another is this route. Okay, and this is the route with one less number of the hop in the route. So the router must follow this route. In static routing we can define the route manually for this route, but in dynamic we are not configuring the network for a specific route, so the router will decide the shortest route once we try to communicate with network 10 to network 20. So it's up to the router to decide the shortest route. So we have to test this thing by configuring the network. So here this first network is, I am using this network ID for this first network 10.0.0.0. Here this at 8 indicates the number of network bits, means I am using class A addressing throughout, and /8 is indicating that we are using first octet to define the network ID. Similarly for this network the network ID is 20.0.0.0. Next, the first host of the network is 10.1.1.1 and I am going to use the same pattern for the second host as 10.1.1.2. okay, now the gateway for this network is going to be this, the next IP address of the network 10.1.1.3. we are discussing the things over slides here so that it can be clearly visible to you whatever configuration or whatever IP addresses I am going to use, and just to keep it simple I am using class A addressing only. Similarly for the second network, this will be the IP address of first host and this will be the IP address of the second host, and the gateway will be 20.1.1.3. okay, so same pattern we are following. Now next network, I hope you can trace out the next network. So the next network is this, one more network is this, and the last network is this. So we are having 3 more networks, so total of 5 networks are available here. So this is your next network with with network ID as 30, and next network is with IP address network ID as 40, and the fifth network is having the network ID as 50.0.0.0. okay, so these are the network that we are going to use. Next, in every network we need to define the IP addresses for the host. So as this is the network 30, so we need to define one IP address for this route, for this node and for this node as well. Similarly for network 40 we need to define one IP address here and one IP address here. Okay, so let's see what we are going to use the IP addressing for these networks. So for this first host of network 30 I am going to use this as the IP address, and for second host I am going to use this as the IP address. Okay, and for network 40 this will be the IP address of the first host. I am considering it as the first host of the network and the second host of network 30. Okay, so there should be no confusion. So this is the second host of the network 40, so IP address is this. So there is no barrier to use 1.1.1.1. so you can use any IP addresses of but they must belong to the same network. For this connection, the IP addresses must belong to same network. For this connection, IP address must belong to same connection. Now the next I am going to use for network 50 as 50.1.1 for this connection, and for this connection I am going to use 50.1.1.2. okay, so this will be the complete configuration that I am going to use. So you can take a screenshot of this and you can configure or assign the IP addresses to your network according to this configuration. Now let's see the practical means implementation of this network with Cisco Packet Tracer. So here we have already added the nodes and already performed the configuration of host, and labels are also added to make the things clear. So let's check the configuration of these hosts. So first host in the network is 10.1.1.1 as we have already discussed, and the gateway is 10.1.1.3. okay, for second host also this is the IP address 10.1.1.2 and this is the gateway. Now we need to configure the router for this network. So let's open the router's configuration, and it is connected to fast Ethernet 0/0, fast Ethernet 0/0. okay, so for fast Ethernet 0/0 turn it on and provide the gateway 10.1.1.3, and the router is configured for this network. Done. Now it's done for the second network. Let's check the configuration of the host. So for the second network, first host is this 20.1.1 and the gateway is same 20.1.1.3. okay, as we have used the same pattern for the network first network as well. For second host 20.1.1.2 and the gateway. Done. Now we need to configure this router. So for this router, it is also connected to fast Ethernet 0/0, fast Ethernet 0/0, turn it on and add the gateway 20.1.1.3. done. Now both routers are configured for their directly connected network. This dot is still red, so it is taking some time. So by the time it is configured, we must turn on the preferences to show the port labels for further configuration. okay, so we can let's just check whether we have configured the routers correctly or not. So we are trying to send a packet data unit from first host to this router and we got the success. Similarly, let's try send something from the connection from host 2 of the network 2 from their directly connected router, and we got the success. Means routers are configured perfectly for their neighboring routers. Now we need to configure the routers for their neighboring routers. okay, so for this, open the router 0. We will be performing the configuration for the neighboring router one by one. For router 0, it is directly connected, it is configured for this connection. Now it is connected to two more networks, network 30 and network 50, and for network 30 it is connected to serial port 2/0. so go to serial 2/0, turn it on, and as it is the first, we are considering it as the first host of network 30, so IP address is 30.1.1 and done. okay, and for serial port 3/0, it is connected to network 50. So let's provide the IP address that belong to network 50, 50.1.1.1. okay, so this router is configured for both of direct interfaces. Done. Now it's turn for the router 1, and router 1 is directly connected to router 0 at the port serial 2/0. okay, so serial 2/0, turn it on, and we have added it as 50.1.1.2 and the gateway is subnet mask is 255.0.0.0 because it's a class A addressing. Now it is also connected to network 40 at the serial 3/0. So for serial 3/0 we need to provide it some IP address of network 40.1.1.2. I am considering it as a second host of the network. So 40.1.1.2 as we have already discussed in the presentation. So done. So router 1 is also configured for all their interfaces. Now we are left with only one router, that is router 2 to be configured. So router 2 is having connection for 2/0 and serial 3/0. So for serial 2/0 turn it on, it is connected to network 30. So 30.1.1.2 done. Okay, and as it was 30.1.1.1, so I have provided the second IP address here, and it is connected to serial 3/0 for the network 40. So let's provide it the address for the network 40.1.1.1 and done. Okay, so our configuration is complete here, means all the routers are configured according to the for the neighboring routers. So let's turn off the preferences. So after this, let's check whether the routers are configured properly for the neighboring routers or not. So let's try sending something from router 0 to router 1, and we got the success. And from router 1 to router 2, from router 2 to router 0. Okay, so we got the success. That means routers are successfully configured for their neighboring routers. So let's try a packet, sending a packet data unit from a host of network 1 to the host of network 20. Okay, and this time we get the failure because routing is not defined. Similarly, if you try sending something from host of network 2 to host of network 1, you will also get the failure because routing is not defined. So let's define the dynamic routing so that routers may choose the shortest path within the connected networks. So for this, open the router 0 first, as we have already learned this, that for dynamic routing we need to configure the router for the directly connected networks only. As we can see, the router 0 is connected to network 10, network 30 and network 50. So we need to define the dynamic routing for these three networks only, network 10, 30 and 50, means direct connects of router 0. So go to RIP, we are not going to configure it for the network static routing. So it is connected to 10.0.0.0 and simply add this network. So it is added. Now next network we need to add is 30, and last network the router 0 having direct connect is 50. So router 0 is connected for network 10, 30 and 50. Done. Okay, now it's turn for router 1 to be configured, and router 1 is directly connected to, go to RIP, router 1 is directly connected to three networks, network 20, 40 and 50. So firstly we are adding the network 20, next we are adding the network 40, and last we are adding the network 50. Done. Okay, the last router we need to configure is router 2, and router 2 is directly connected to only two networks, 30 and 40. So simply add two networks, 30 and 40. Done. Okay, so our routing is complete. We have successfully defined the routing tables for these routers. So let's the router to choose the shortest path within these networks. So let's try sending the packet data unit from host of network 1, host of network 10 to host of network 20. Okay, so first time we got the failure. So let's try again. The routing tables are routers are exchanging their routing table and they may take some time to decide the route. So let's try again, and this time we got the success. Okay, so let's delete this failure Now we got the success, and let's simulate whether the router has chosen the shortest route or the longest route, means this route or this route. Okay, so let's see this. Router 0 is now to should choose the short. Yes, now router 0 has transmitted the packet to router 1, and router 1 will transmit the packet to the network 20. Okay, so the router has not chosen this route because it was having one more hope, means one extra hope to travel to transmit the packet. Okay, so so this is the dynamic routing. So static routing is not preferable in this case where we have multiple routes and multiple networks connected to the router. So we must use dynamic routing because it will always choose the shortest route. You can also try it with other dynamic routing protocols like OSPF, EI, GRP. You will get the same scenario. Okay, so that's it for this video. Bye and take care. See you in the next video.